You might think that UY Scuti is the biggest star in the universe. After all, when scientists discovered it, they were amazed by its size. It has a volume of about 500 million times the volume of the Sun. That's huge. But as research progresses, we have found that UY Scuti is not the ultimate champion of stellar size. Let's first take a closer look at UY Scuti, the star that used to hold the record for being the biggest. Despite its enormous dimensions, UY Scuti appears as a faint twinkle in the night sky due to its immense distance from us, approximately 9,600 light-years away. If we put it in the center of our solar system, it would swallow all the planets from Mercury to Mars, including Earth. We would not survive. UY Scuti, located in the Scutum constellation, is an awe-inspiring star that stands out in the universe. It is known to be one of the largest known celestial bodies, with mind-boggling dimensions. Its estimated radius is about 1,800 times greater than that of the Sun. To put it into perspective, its volume could accommodate nearly 5 billion suns. Not only does UY Scuti possess impressive size, but it also radiates with astonishing luminosity, outshining the Sun by a factor of around 350,000. While it shares similarities with Betelgeuse, a variable star, UY Scuti displays more subtle variations in brightness, demonstrating its gentle fluctuations. Luckily, it is far enough from us that we don't have to worry about its future supernova explosion. UY Scuti is so big because it is dying. It has become a red supergiant, a type of star that rapidly expands once it runs out of fuel. This stellar giant has undergone an extraordinary journey over approximately 8 million years. As it nears the end of its life, UY Scuti has nearly consumed its hydrogen and helium fuel and is now fusing heavier elements in its core. Eventually, the gravitational forces will cause UY Scuti to collapse under its own weight, leading to a spectacular event, a supernova explosion. However, there is also a tantalizing possibility that UY Scuti may experience an even more remarkable destiny, an explosive hypernova that will generate gamma-ray bursts, lighting up the entire cosmos for weeks. You may have heard of red giants, stars that grow bigger and redder when they die. Our Sun will become one of them someday. It will expand so much that it will reach the orbit of the Earth. But red giants are only for stars that are not very massive, like the Sun or smaller ones. Stars that are much more massive than the Sun become red supergiants, or even red hypergiants when they die. These are the biggest and brightest stars in the universe, and they will end their lives as black holes. The hypergiant star Stephenson 218 is located in the Scutum constellation, and it astounds us with its immense size and brightness. If we were to place this star at the center of our solar system, it would engulf almost half of it. With a radius approximately 2,200 times larger than that of our Sun, and a luminosity surpassing the Sun by about 500,000 times, Stephenson 218 is truly remarkable. Stephenson 218 is the biggest star that has ever been observed by scientists, but it may not be the biggest star that can exist in the universe. There is a theoretical limit to how big a star can be, called the Eddington limit. It depends on the balance between the outward pressure of radiation and the inward pull of gravity. If a star exceeds the Eddington limit, it will become unstable and lose mass through powerful winds or eruptions. The Eddington limit for stars with normal composition is about 150 times the mass of the Sun. But some stars may have different compositions, such as more helium or less metal, that allow them to grow bigger. Stephenson 218 has a mass of about 100 times the mass of the Sun, so it is below the Eddington limit. But there may be other stars out there that are closer to or even above the limit. We have not found them yet, but they could exist in some remote corners of the universe. Honing in on the Stephenson 218 poses a significant challenge as it is situated approximately 20,000 light-years away from us. This distance location makes it difficult for astronomers to study this giant star. Adding to its intrigue, Stephenson 218 exhibits interesting changes in brightness and size over time. It is classified as a semi-regular variable star, demonstrating both patterns and irregular variations. It is also an eruptive variable star, capable of power energy bursts and matter either due to conventional or stellar winds, magnetic activity, or nuclear reactions. Despite its size, this stellar giant is relatively young Earthly, around 3 million years old. Like Uy Scuti, Stephenson 218 is also a dying star. It is burning its fuel very fast, and it will not last long. It has already consumed all of its hydrogen fuel and has been fusing helium in its core. In the future, it will deplete its helium reserves and initiate the fusion of heavier elements like silicon and carbon. This transition will render the star more unstable, eventually leading to a massive supernova explosion. This extraordinary event will illuminate our galaxy for several weeks or even months. With a countdown to the supernova ticking away, Stephenson 218 could unleash its dazzling spectacle any time within the next 15 to 60 million years, just like Uy Scuti. Any planets or life forms around Stephenson 218 would have no chance to survive. They would be devoured by the star's expansion or destroyed by its explosion, and that is a very hostile environment for life. Betelgeuse is another remarkable red supergiant star located in the Orion constellation that holds great significance in the night sky. It is known for its impressive size and brightness, shining brighter than many other stars. Betelgeuse is 1,000 times wider than that of our Sun. To put it into perspective, if we were to place Betelgeuse in the middle of our solar system, it would extend close to Jupiter. Its luminosity is equally astonishing, emitting approximately 100,000 times more light than what we get from the Sun. Although Betelgeuse is situated approximately 650 light-years away from Earth, it is an intriguing object for astronomers to study due to its relative proximity in astronomical terms. We can easily observe this fascinating star using telescopes. What sets Betelgeuse apart is that it constantly changes in size and luminosity. This pulsating variable star expands and contracts due to the rise and fall in temperature and pressure in its core. It has also been speculated to be an irregular variable star, meaning it does not adhere to a fixed variation cycle. Various factors such as dust formation, convection currents, magnetic activity, and stellar winds contribute to Betelgeuse's sudden and striking changes in brightness and color. Impressively massive, Betelgeuse has an estimated mass of more than 15 times that of our Sun. Moreover, this star has been in existence for approximately 8 million years, indicating that it is nearing the end of its life cycle. It has nearly depleted all of its hydrogen at its core and has now commenced the fusion of helium. Betelgeuse is also nearing the end of its life, and in the next 100,000 years, it will explode into a supernova. VY Canis Majoris is another massive red star located in the Canis Major constellation. It is a giant star with a massive approximately 24 times that of Earth's Sun, and a brightness about 275,000 times greater than our Sun. To provide a sense of scale, VY Canis Majoris is almost 1,500 times larger than the Sun, which means it would extend almost as far as Saturn if placed in the center of our solar system. Despite its grandeur, VY Canis Majoris is quite distant from Earth, approximately 4,000 light-years away, which explains why it can't be seen with the naked eye from Earth. VY Canis Majoris has a unique spectrum that does not neatly fit into the current star classification system. Although typically classified as a highly luminous M-type star, its spectrum exhibits hydrogen lines with P Cygni profiles, a characteristic commonly found in luminous blue variable stars like the Pistol star, Eta Carinae, and Ray 1796. Interestingly, the surface temperature of VY Canis Majoris averages around 3,500 Kelvin. This is due to its exceptionally large radius, which results in a significantly larger surface area compared to other stars. Consequently, its luminosity depends on at least 25% of its temperature. Even a slight decrease in temperature leads to a substantial reduction in brightness. VY Canis Majoris has exhibited its distinctive red color since 1847. Scientists have been observing the fluctuations in its temperature. In 1917, Guerin and Perrin independently reported visual magnitudes ranging between 8 and 9. This was followed by Florger and Robinson's observations in 1935 and 1937, which recorded magnitudes of approximately 9 and 8 respectively. This decline in brightness could be attributed to a denser region of the star's surrounding envelope obstructing its light, a phenomenon known as extinction. Alternatively, there may have been a change in the star's emission. Canis Majoris is not visible to the naked eye, but it becomes discernible through binoculars or any average telescope. It is classified as a semi-regular variable star and is believed to have a period of about 2,000 days. However, as a hypergiant star, it rapidly loses a significant amount of mass, shedding approximately 30 times the mass of the Earth each year as it approaches the end of its life. This mass loss will lead to an explosive supernova event in which the star will detonate, releasing a mixture of dust and gas into space due to the pressure from its radiation. This material continues to expand outward indefinitely. Scientists predict that VY Canis Majoris will experience a supernova event within the next 100,000 years. When massive stars like VY Canis Majoris reach the end of their life cycles, they often leave behind black holes instead of neutron stars. And that brings us to the end of this video. If you like this video, click on the screen to watch other videos like this one. Don't forget to like, subscribe, and click on the notification bell to get notified when we post a new video.